All right, so anybody with a question? I'll say, let me hide my face to see if you're gonna ask questions. Any questions on the assignment that you want me to work on?
From the homework?
Of course.
Let me find it real quick. There was one that had a really big. We do 7.5, number 8.
Read the problem for me.
It is y double prime minus 4y prime plus 4y equals t to the 3rd power.
Mm-hmm. That's not all. That's not all. There's still something missing in the problem.
Oh, did I forget the? Hold on. Y to the 0 equals 1, and then y prime 0 equals 0.
Someone there with a noise. And so the good thing about doing this is that you actually see what you're going to plug in. And most of the time when people don't do this, it ends up with mistakes. And the other thing is that this very example is exactly the one that we solved in class last time. So I'm going to use a different method to work on this now. So we plug all this in there. That's s squared, the plus transform of y, minus s, minus 4s, the plus transform of y, plus 4, plus 4 Laplace transform of y equal, and I leave this as a Laplace transform of t cubed. And that's going to be s squared minus 4s plus 4 Laplace transform of y equals s minus 4 so Laplace transform of y is s minus 4 over s minus 2 squared plus 1 over s minus 2 squared Laplace transform of t cubed. And this is 1 over s minus 2 minus 2 over s minus 2 squared plus, and this is a plus transform of t e to the 2t. Therefore, we get y equals inverse Laplace transform. This is e to the 2t minus 2t e to the 2t plus, and that will be t e to the 2t convolution with t cubed. So what you need to do now is to write this convolution and compute. Next question.
I had one more. It's going to take me a minute to match it up with what I did wrong on the homework.
What is it? What's it, the one you? The problems probably start by this, by giving me the wrong Laplace transform of derivative.
Actually, that was the only one I had questions on.
Who's next? You have 5 minutes to solve this. Similar to what's just written there, difference is the function, f of t is the step function. So you need to use a definition of the Laplace transform to get the Laplace transform of that function. So who's done? And you got to be very careful when you're answering questions to know what goes to what topic. So when you're asked to use convolution, that's convolution. When you're asked to use the first translation theorem, that's first translation theorem. And try the answer and can't hear you.
I'm still working on it, almost.
Let's go together. All right, let's start this with someone. Anyone? Cooper?
Hey, your audio cut out. Did you say my name?
Yes, I said let's start solving this. What's the first step?
I'm having a lot of trouble. I'm not really sure where to start.
Ethan?
First, I took the Laplace of everything. So the Laplace of y prime plus 3 times the Laplace of y equals the Laplace of f of t.
Mm-hmm.
And then I solved for the Laplace of y prime to be s times the Laplace of y minus 1 plus the rest of the problem.
And what's the Laplace of y of t? Of f of t?
All right. That is the integral from 0 to 1 of t e to the negative st dt plus the integral from 1 to infinity of e to the negative st dt.
That's it. And now we can do this. So when we integrate this, what do we get? So we get t e to negative st over negative s to take from 0 to 1 minus the integral of that. So it will be minus e to negative st over s squared, I guess. And then 0, 1. And then you'll get this integral. It's e to negative st over negative s, 1 to infinity, right? So what is it equal to? You get e to the negative st over negative s minus e to negative s. So this is negative s over s squared. And then you plug in 0, you get 0. Plug in 0 here, go 1 over s squared. Is that correct? And then when you plug in here, you plug in 1, you get e to negative s over s. Is this true?
Will the first and last two cancel out?
This is plus, right? And this cancels with that. And so you get a plus transform of y times s plus 3 equals 1 plus 1 over s squared minus e to negative s over s squared. And now you can divide. You get Laplace transform of y equals 1 over s plus 3 plus 1 over s squared times s plus 3 minus 1 over s plus 3 s squared e to negative s. And notice that this thing here is exactly the same that you have here. The only difference is that you're multiplying by e to negative s. So now the way you end this problem depends on your skills. So y is the inverse Laplace transform of 1 over s plus 3, 1 over s squared s plus 3, minus 1 over s squared s plus 3, e to negative s. You can do partial fractions, and you can do convolutions. So the inverse Laplace transform of that is going to give you y of t equals, first part is e to negative 3t plus, if I use a convolution on this one, that's 1 over s squared times 1 over s plus 3. 1 over s squared is t, and then 1 over s plus 3 is star e to negative 3t. If you don't want to do this, you can go ahead and do your partial fractions and then find your answer. And then this, what is remaining, that third part is minus, because of this thing here, either minus s which means we need to shift by 1, right? We need f of t minus 1 times u of t minus 1. So f of t that gives this is that function. So that is t star e to the negative 3t. And then we take that function and we replace t by t minus 1. And then we multiply by u of t minus 1. That's why I say it depends on your skills how to finish. And now what all you need to do to finish this problem, as you can see from what is written, is find this convolution, compute it, and plug into that formula, and you got y of t. Now, how do we compute this convolution? I'll do this in this problem, because one of the questions you answer certainly will be use the definition to find the convolution of something. So t star e to negative 3t equals integral 0 to t, and this is going to be tau e to negative 3 times t minus tau e tau, which is integral 0 to t tau e to the 3 tau minus 3t e tau. Now that's equal tau e to the 3 tau minus 3t over 3, 0 to t minus integral of e to the 3 tau minus 3t, 0 to t over 3 d tau. And that is tau e to the 3 tau minus 3t over 3 minus 1/9 e to the 3 tau minus 3t. You plug in 0, then you plug in t. When you plug in t, you get t over 3. Then e to the 0 is 1 minus, when you plug in t, this is 1/9. Then we plug in 0. This piece is 0. When you plug in 0 here, that's minus 1/9 e to minus 3t. So that's what that convolution is equal to. Simple. And so you're going to take that function, replace t by t minus 1. So the answer to the problem is e to minus 3t plus t over 3 minus 1/9 minus 1/9 e to the minus 3t plus this same function in which you replace t by t minus 1. That becomes t minus 1 over 3 minus 1/9 minus 1/9 e to the negative 3 times t minus 1. All of that multiply by u of t minus 1. And that's how you finish that problem. There is still some algebra that can be done in between there, but it's completely unnecessary. Any questions? How do we find the inverse Laplace transform of this thing? What's the rule that we use? Anyone to answer that question? Misha?
I don't know the exact rule verbatim, but don't you take the negative inverse Laplace of the derivative with respect to s of the inside of the function?
That's the rule.
And don't you have to break it up into the inverse Laplace of the natural log of s minus 1 minus the inverse Laplace of the natural log of s plus 2?
Just to make it easier to compute. That's right too.
I just didn't know the name of the rule. I was looking for it because I thought there was a specific name.
Yeah, there is. It's derivative of Laplace transform. That's where we use that. So like we said, it's negative inverse Laplace transform, and that's negative 1 over t inverse Laplace transform of d over ds of whatever is inside. And because of the form of it, it's better to split first. Otherwise, you're going to get in trouble taking derivatives of natural log. When you split like this, the problem gets simple. And so that's what you do. Negative 1 over t. That's the topic is derivative of Laplace transform. And now you take that derivative of natural log of s minus 1, that's 1 over s minus 1. And this is 1 over s plus 2. Now you tell me, what's this going to be equal to? What's the inverse?
Isn't it e to the t minus e to the negative 2t?
That's it. So what would you think? What's the topic that you need to use here in this one? James.
Wouldn't you use partial fractions for this one?
You use the partial fractions when you are able to factor out the denominator. Can you factor out the denominator in this case?
No, you can't.
So what can be done then? Was that
You
a
use the translation theorem.
good? You use the first translation theorem. That's the only way around here, because you want to push that denominator to look like a sum of squares, and then use the first translation theorem to solve the problem. So this is now the hint that you have. You need to use the first translation theorem. Let me give you 1 minute to think about that, and then we go on. Who wants to try? All right, let me call someone to help Michael.
I'm not really sure how to do it.
I was talking about Michael Hill. Is he there, Michael? So just the picture of the first letter of his name is here. Dakota.
First I simplified like the bottom, like the denominator.
What do you mean? How?
I did like s minus 2 over s minus 1 squared plus 4.
All right, that's the right thing to do. So that's s minus 1 squared plus 4 over s minus 2. And now at this point, you are ready to do the first translation theorem. How is that done?
Isn't it s?
We replace this by s, right?
Right. Well, s minus a.
Because of s minus 1, we multiply by e to the t, e to the at, right?
Right.
And now, inverse Laplace transform of, and you replace everywhere s minus 1 by s. That becomes s squared plus 4. And this becomes s minus 1. That's how you do first translation theorem. Replace s minus a by s. Then you multiply by e to the 80. And now that is e to the t times s over this is cosine 2t, and minus 1 over that is minus 1/2 sine of 2t. That's it. Use the convolution theorem to find inverse Laplace transform of 1 over s times s minus 1 cubed. Let me give you a few minutes, 2 exactly, to do this. Thank you, Dakota. That was a and Arthur, can you tell us here what would be the first step in this problem? Is Jimmy here? Charlie?
I haven't gotten around to learning the convolution theorem yet, so I'm not too sure how to do this one.
My friend, the test is on Thursday. It's just in 2 days.
Yeah, I got the first 5 lectures down, not that one though.
Yeah. Preston,
Yeah, so you'd break it up to 1 over s and 1 over s minus 1 cubed.
thank you. That's exactly what needs to be done. So this is the Laplace transform of 1 over s times 1 over s minus.
Wouldn't it be
That's all right. And I always say take the constant back in front. Minus minus, that's plus 2 e to the tau, e to the t, and then we plug in 0 and we get minus. It is to do this at this point. If you don't want to do that, you're going to have here partial fractions 1a over s plus b over s minus 1 plus c over s minus 1 squared. It saves you time, a lot of time. If no questions, let's do another problem. Find that's problem 6 using the definition. Laplace transform of t sine 2t. Who wants to go straight with me on answering this? Want to try, Devane? Hello? William?
I'm so sorry. I kind of zoned out right there. I'm still working on it.
Well, I suppose we can go together, and so I'll just wait till you finish.
I'm trying to find the formula to use here. Because was there one like this on the homework or no?
It was.
Okay.
Do we use a over s squared plus a squared?
Is that again? I said use the definition. I understand what you're talking about. That's a theorem. And when you say use the definition, it means you write down the integral and compute.
In this problem, are we allowed to use the definition of negative d ds or the Laplace of t ft equals negative d ds Laplace ft?
That's not a definition, that's a theorem. There's only one definition of the Laplace transform. From the first section on that topic, it's an integral.
Isn't it just the integral from 0 to infinity of like t sine 2t dt?
Something is missing. T sine 2t, then
Times e to the negative st.
e to negative st. That's a definition of Laplace transform. There's nothing else that is accepted when the question is find using the definition. You need to write that definition and compute that integral. Anything else is a theorem that is proved in the book. But this is where it all starts. That's a definition. Okay. All right. There's technically here what I wanted to get you to do was this one. Where you need to combine the two things. To write like this, and then compute by parts the integral. And in the integration by parts, this is going to be dv, and that's going to be u. And so du is going to be 2 cosine of 2t dt, and v is going to be e to negative s minus 1 divided by negative s minus 1. And so that is equal to uv sine 2t e to negative s minus 1t over minus s minus 1, 0 to infinity, minus integral 0 to infinity of 2 cosine 2t e to negative s minus 1t over negative s minus 1 dt. When you plug in infinity here, under the condition that s is larger than 1, this goes to 0. And then you plug in 0, the sign is 0. So this first integral is a 0. That's probably smiling. And then you have minus and those things come out. You go 1 over s minus 1. And then you have that 2 here. Integral 0 to infinity cosine 2t e to minus s minus 1t dt. And again, this continues to be dv. And now this is u. So du is negative 2 sine 2t. And v is the same as before, e to negative s minus 1t over negative s minus 1. So the whole thing is equal to 2 over s minus 1 times uv. So that's cosine 2t e to minus s minus 1t over minus s minus 1, 0 to infinity, minus integral 0 to infinity. That's minus 2 sine 2t e to negative s minus 1t over negative s minus 1 dt. And now, and this again, that's Laplace transform of f of t equals that. If you plug in infinity, again, because s is larger than 1, it's a 0. When you plug in 0 this time, you get 1. Because e to the 0 is 1, cosine of 0 is 1, minus and minus, that's a plus. So you get 2 over s minus 1 squared with this one. And then minus, 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 that becomes minus 2 and 2, that's 4, over s and this, maybe s minus 1 squared. And what is left is integral from 0 to infinity, sine 2t e to negative s minus 1t dt. And this is exactly what we started by. So that's again Laplace transform f of t equals 2 over s minus 1 squared minus 4 over s minus 1 squared Laplace transform of f of t. Now you can bring it back to the other side. You get 1 plus 4 over s minus 1 squared Laplace transform of f of t equals 2 over s minus 1 squared. You bring this to the common denominator, you get s minus 1 squared plus 4 Laplace transform f of t equals 2. From where you can solve Laplace transform of f of t equals 2 over s minus 1 squared plus 4. So the theorems that you use and that you wanted to use come from this, which is proven in general. But in the problem, when you're asked to use the definition, what you need to do is use the definition, which is the integral. Take that integral, compute it. Any questions on this? Okay, next problem. This is problem 7. So this is the thing. And the question is, find this Laplace transform. You need the ideas first before doing. What's the idea you have here? What topic? Hello?
Would you use the formula we found in Laplace transform a derivative where the Laplace of integral of 0 to t g tau d tau equals 1 over s times the Laplace of g of t?
Can you say that again?
I believe we would use the formula that the Laplace of an integral from 0 to t of g tau d tau equals 1 over s times the Laplace of g of t.
Be careful. Look at what is written inside there. Careful. That's not a function of tau that is inside here. You have tau here and you have t minus tau there.
Can we use the definition of the convolution theorem? Because it would be cosine t star sine t.
Correct. So for this part, you have a convolution. I agree with you, but that's not all. There is something else. What you've said is correct for the step 2 in this problem. And in step 1, what's the first thing you assume? That brings in another theorem. Before getting to this integral, what do you have?
Is it the t on the outside of the integral?
You have a t outside the integral. How do you handle a t in a function?
Did you just use the theorem given, which is the Laplace of t is equal to 1 over s squared?
It's not t by itself, it's t times something.
So if you evaluated that integral, it would be a function of t, and then you could use the derivative of a Laplace transform where the Laplace of t times the function of t is negative dds times the Laplace of the function of t.
That's correct. So that's the first step in this problem, is to use the derivative of Laplace transform to get rid of that first t before getting to the convolution that is inside. So that is negative derivative with respect to s of the Laplace transform of what is inside. Anytime you see t, that's how it's handled. When t times something, t times something, it's negative derivative of Laplace transform. And now, what Aaron was saying is the second step here. Now this here is a convolution. Laplace transform of a convolution is the product of Laplace transform. So this is negative derivative with respect to s of s over s squared plus 1 times 1 over s squared plus 1. It's negative derivative with respect to s of s over s squared plus 1 squared. So you got to take that derivative and multiply by minus. And so that's over s squared plus 1 to the power 4. Derivative of this times s squared plus 1 squared minus derivative of this 2 times 2s, that's 4s times s squared plus 1 times s. And so s squared plus 1 can cancel. You get s squared plus 1 minus 4s squared over s squared plus 1 cubed with a minus sign. And that turns into 3s squared minus 1 over s squared plus 1 cubed. So that's how you would find the Laplace transform in this question. So basically, you need to be aware of what goes where, what brings in which of the theorems that you have studied. You have t times something, that is calling for the derivative of Laplace transform. If you have e to the 8t times something, that calls for the first translation theorem. If you have e to the negative as, that calls for the second translation theorem. You have a product of Laplace transforms, then that calls for a convolution theorem, and so on. Any question on this? So now find the Laplace transform of t squared plus 5 e to the times u of t minus 1. What do we use in this case?
Second translation theorem.
Second translation theorem. So you need to see f of t minus a and u of t minus a. So you need to know what is f of t and what is f of t minus a to figure out what is the a and get this formula. Let's give you 2 minutes. Okay, so there's something to share here. So what is f of t minus a? What is a?
A is a 1. So to find f of t minus 1, you could take the function you're given, t squared plus 5, and plug in t plus 1 for every t.
No, you are going backwards. That is done when we do that one when we go from the Laplace transform to the inverse Laplace transform. But here, I guess I guess I'm going to say something. Thank you. Technically, so f of t minus 1 is exactly what is standing here. That's what I want to say. Okay, because that's what you see in the formula. A is 1, f of t minus a, you replace a by what you got as a, and you set that equal exactly to what is here. And now from here, you're going to find f of t. Is that what you were saying?
Yes, sir.
Okay. By replacing now, because it was t minus 1 here, we're going to replace here t by t plus 1. And that is going to be t squared plus 2t plus 6, and it's okay, important to open that like that. And so now that you have t, now you can find Laplace transform of f of t, which is a Laplace transform of t squared plus 2t plus 6. Laplace transform of t squared is what? 2 over s cubed, 2 over s squared, 6 over s. And so the Laplace transform of t squared plus 5 u of t minus 1 equals 2 over s cubed plus 2 over s squared plus 6 over s e to the minus s. That's it. Any questions? Again, you start at a equal 1 because that's what you're seeing in here. That's a. That's why we start by a equal 1, because we are seeing that in u of t minus a. All right. If you guys have no questions, then I'll just say thank you, and hopefully you get 100% on that test coming on Thursday, and we'll be fine.